So we are going to do PLC SCADA DCS lab. We will be seeing one by one the experiments. So out of 10 experiments, we will be doing the second experiments today. So alarm handling and bottle filling system with the PLC. So this alarm handling we will be doing with because of software. Bottle filling system we will be using G5 PLC for real-time process control. So this alarm handling I will be showing through PicoSoft simulation. Bottle filling system you can do only through real-time operation. So today the aim of this experiment is to design and develop a alarm control and bottling filling system and to control it with PLC. Okay, so in order to do alarm control, we have a problem for that alarm control. That is, so we have a safety alarm system, that is fire alarm system. Let us take. So there are 4 sensors used for this fire alarm system. If any one sensor become true, then there is no action taken. If 2 sensors become true, then a red light should come on. If 3 sensors becomes true, an alarm should count, and all the 4 sensors become true, fire department is notified. That is the problem given for the PLC operation. So if any 2 sensors become true means actually there are 4 sensors. Then how many operations we will be having? Any 2 sensor becomes true means we will be having sensor 1 and 2, 2 and 3, 1 and 4, 1 and 3. So there are combinations of this, different combinations are there. That can be about 6 combinations we will get, 1, 2, 2, 3, 2, 6, like that. So when you come to with these 6 combinations, we will be using this particular system. Okay. So then 3 sensors, any 3 sensors become true, then there is another alarm count comes. That is, any 3 sensors become true means 1, 2, 3, or 1, 2, 4, then 2, 3, 4, then 1, 3, 4. So there are about 4 combinations will come under this condition. Then all 4 sensors become true, then department is notified. That is the program we are going to do. Let us do this program with PicoSoft software. So I am taking the PicoSoft software. So already I am having the program, right? So any 2 sensors become true, any 1 sensor become true, there is no response, that is given. So any 1 sensor become true, 1 input, nothing happen. So we no need to write the program there for this particular one. Second case is any 2 sensors become true. So there is a combination of that much sensors. That will be like you can see 2 power n minus 1 combinations we can take. So that is 6 combinations will come. 2 power n is 4, 4 minus 1 3, 2 into 2 into 2, we will get 6 combinations we will be getting. So 1 2 1 3 1 4 2 3 2 4 3 4. There are 6 combinations we will be getting for any 2 sensors become true. Then what is the output condition? We should get output Q1 true. Q1 should come on when any 2 sensors are true. Then any 3 inputs are on and alarm should come on. So any 3 sensors true becomes means 1 2 3, that is combination. First sensor will become true and second sensor and 3, or 1 2 4, or 1 3 4, and one more is there. So we will have one more connection. So that is I1, I3, I4. So 4 combinations we will get for this particular system. So all 1 2 3, 1 2 4, 1 3 4, or 2 3 4. So under these combinations only all these 3 sensors will become true. Then the last combination is all the sensors become true, but in PicoSoft we can have only 3 contacts in a single rung. So we are using a memory. So this memory we are taking, you can see. So we have 4 combinations here, I1, I2, I3. Instead of having 4 rungs in a single 4 contacts in a single rung, we cannot make in PicoSoft, so that we are using a memory. So this memory we can take from M. So we can have M1 or M2, which is 16 memory address we can use. So from this memory we are going to use I4, then I will get an output Q3. So we made 3 programs, you can see, for Q1, Q2, Q3. Q1 is a combination of 6 things: I1, I2, I1, I3, I1, I4, I2, I3, I2, I4, I3, I4. So these all are AND operations. Then parallel operations are these all AND operations, parallel are OR operations. These are the maximum combinations which are available for this particular circuit for the program what we have. So any 2 inputs are on, 1 light will come. Here we are also instead of alarm we are going to see 1 light. Again 4 inputs are on, a fire department is notified. There is also discrete output, so that will be shown by an indication. Let us go for a simulation of this process. You can see, so we have 1, 2, 3, 4 inputs. So any one input is true, you can see one input, first sensor is true, no output is coming. Second sensor true, no output is coming. Third sensor is true, no output is coming. Fourth sensor is true, only fourth sensor is true, no output is coming. Any 2 sensors true, 1, 2, you can see one output coming, Q1 is coming, or 1, 3 you are getting, or 1, 4 we are getting. 1 and 2 or 1 and 3 or 1 and 4 we will be getting. Same case, 2 and 4 or 3 and 4. So let us see, any 2 sensors become true, we are getting a Q1 output. Then any 3 sensors true, you can see the second output is coming. Always this Q1 will come because the program says that only this will come. There is no program telling like that. So it will, both will come. So this is 1, 2, 3, 1, 3, 4 or 1, 2, 4 or 2, 3, 4. On any combination we will get Q2 also output come. Then the last case available is all the sensors become true, we will be getting the third output. So this is the condition we made for this particular program. Any 2 inputs are on, pilot light should come on. Any 3 inputs, any 3, if all 4, then your output should come. So this is the program we are making simulation through this PicoSoft PLC. This program you can make your own in your personal computers and use it for lab purpose. So we are going to see programmable logic controllers, bottle filling system with PLC. So here we are using Fanuc PLC. So G Fanuc PLC we are using. So it is having about 14 inputs and you have 10 outputs. These 14 inputs are digital and these 10 outputs are also digital also digital. So we have one analog input and one analog output, so which can be used as voltage and current. So this is a G Fanuc PLC we are going to use. So in this bottle filling system we have different sensors available. So the sensors available are given here. One is bottle indication sensor, bottle position sensor, low level sensor and high level sensor. So you can see the diagram of this bottle filling system here. So we have a tank. From that, water is taken through a motor which is given for a overhead tank. So this is the overhead tank available. So from there, through a solenoid valve, bottling station is there. In this, bottles are fixed, and this is driven by a stepper motor. So we will see this first. What are the sensors available? So we have high level and low level sensors. So this is in the overhead tank we are having. This high level and lower level sensors are equipped so that we will get a constant flow of water or any material to the bottling station. So when this lower sensor is false, it is indicated that there is no required level of fluid available in the tank. So that what will happen, this motor will work and it will fill the tank. When high level is reached, the motor is stopped. So that is the condition for this reservoir tank. So if these two sensors, if this low level sensor is true only, then total entire process will work. Otherwise the process will not work. It means for the PLC logic that there is no minimum required water level. Then from the tank, the bottling to the bottling plant, the liquid is coming through a solenoid valve. So from the over tank, the water is coming to the bottling station through this solenoid valve. So when this solenoid valve is on, the liquid from the over tank will be coming to our bottles. So this bottling plant is running through a stepper motor. Stepper motors are given through wirings. So we have about 4 step angle is there. So each step angle 4 coils are there. These 4 coils are given power supply alternatively, so that you will make a step angle. So when you change the speed of that step angle, then you can increase the speed or reduce the speed of this particular motor. Okay. So this is for only rotating this system. Now we need to identify whether bottle is present in the system or not. So that is the main thing. You have to find out whether there is bottle in this system or not. If there is no bottle in this particular system and your fluid is flowing from here, then what will happen? Then you will have a spillage of fluid here. So that in order to avoid that, we have a sensor here. So that is an IR sensor will be here. So that will sense whether bottle is present or not. Okay, the sensor will be fixed here and it will be sensing whether bottle is present or not. Now we need to know whether bottle is present in some places or some other places. Now we need to identify whether the position is right for bottle filling. So when it is kept here, then only it will directly go to the opening of the bottle. So in order to identify that, we have a proximity sensor. So this proximity sensor will identify whether this position is right position for filling. So that will be identified by this proximity sensor. So this are the sensors available. We have a bottle sensor will be IR sensor, then we have a proximity sensor which senses the position of the bottle came or not, then low level and high level sensors for the overhead tank. Then we have the output. There are 2 outputs. One is the solenoid valve, so which will on or off the fluid coming in. Now you want to fill this tank 100 ml or 200 ml, that will be made through a PLC program. So timing will be made as a logic for filling this particular system. Another one output is stepper motor, that is a step angle is given for rotating this system. So we will be seeing the bottle filling system program for the PLC we are using. So these are the PLC programming. We are going to use Versa Pro software. So this Versa Pro software we can use for this is of GFNUC PLC. We will be using we will be programming with a new folder name. We can take this PLC. So this programming window will come. So we have the contacts. We can take the contacts and place coils, this same like that we have did for systems. So in this we are choosing the hardware configuration. This hardware configuration we are using a different hardware configuration, so we can replace our module. This is the CPU we are using is fourth CPU, so we will be using fourth CPU. So that CPU we need to install instead of 4, 5, 6 we have to install. So this is one update we have to do. Then we can take these contacts and we can give the numbers for this. So we are giving one input that can be given. So this is how you can make programs. So here this is the program for bottle filling system. So in this you can see this first two I told you, no, this is two inputs are there, I1 and I2. These two inputs are for overhead water control. So when I1 and I2 is for water level control, when it reaches the total top, when it is full, then it will be off and the motor is off, and when it is not full, it will be open. So here we are using timer for filling system. So we are using an on delay timer, so which is having a registry address, and we will be using a memory address. So when this on delay timer we are giving for 5 seconds, so that we will storing to memory. So we have the solenoid valve for output on and off. So this Q6 is the solenoid valve which is used for your fluid flow out and off. So when you then we have a bit sequencer. This sequencer instructions we have seen in the PLC programming. This bit sequencer is used for stepper motor control. So we are starting this is the starting address. Then what is the number we have? Number of coils we are using 4. Then you want to reset, you can make through this. Then you want to change the direction. Input 7 we put on, then you can change the direction. This is how this instruction will be running. So this we are giving the output to 1. The first coil we have, first output will be taking for first coil, then second output will be taking for second coil, like that, third and fourth. So on what sequence we have to give the supply to these 4 coils, that can be given by another one timer. So this is giving in 5 milliseconds we will be giving one changing in the output sequence. So first 0th second we will be getting in first coil, 5th millisecond we will be getting in the second coil, 10th millisecond, like that we will be getting a continuous change. So this 40 memory, from the memory 40 it is connected to bit sequencer. So this is the one output which is for stepper motor control. Another one is for so this Q6 we are giving for solenoid valve on and off, and Q1 to Q4 through this bit sequence we are operating the stepper motor. This is the programming. So for motor on and off we are using another one. So 2 sensors are there. One is for bottle sensor, another one is bottle position sensors. So these are used for the purpose of running this program. So let us see the real time working of this process while running. So this can be run. So you can download the program, you can connect the PLC through default COM probe. Right, we are connecting this program to the particular PLC. Now you can store the program. You can select all these 3 buttons to store this particular program. This program is now stored to the PLC. This is we are doing real time. So this is stored to the PLC. After it is stored to the PLC, we can run the program. So while running, we can see how it is running from the PLC. Store to the PLC is completed. It is online. Now you can put run condition. Now our PLC is running. So we will see from the PLC how it is happening. This is rotating. So when the sensor become true, due to our program it is stopped. Now the solenoid valve is open, since we don't have fluid, it is not coming, so it will be coming. Okay, so now the stepper mode is stopped because that is we have the bottle and bottle position in the same thing, so it is stopped. Then the timing is over, it again starts rotating. So then second bottle comes, it stops and it will deliver the fluid into the bottle. So this is for the bottle filling system. So if anybody is willing to do this experiment through remote desktop, we will be giving remote desktop operation. You will be given time for afternoon sessions. You can connect this PLC through remote desktop and you can operate from remotely. You can program and you can operate. So in alarm handling and bottle filling system with PLC, this is the document you need to submit. Out of this program, you have to put in PicoSoft software and you have to run the logic and you have to paste the diagram here. Then we have this bottle filling system. This bottle filling system is splined to you, right? So you need to put the diagram for bottle filling system using PicoSoft or Logix Pro, and then you have to paste here. Okay, the diagram will be sent separately. You have to use that diagram. You have to do the logic either in PicoSoft or Logix Pro, and you have to paste here and you have to submit this document.